Welcome to This Explainer. I am absolutely thrilled you're here today because we're looking at something that really forms the bedrock of every single successful science classroom out there. We're unpacking the core standards for managing a science lab. And when we talk about running a lab, we're really talking about balancing two massive, totally distinct responsibilities. On one hand, you've got the rigorous management of hazardous inanimate materials. We're talking your chemicals, your glassware, your electrical equipment. On the other hand, there's this incredible, profound responsibility of acting as an ethical steward for living subjects. It's a dual mandate, really. Strict, rigorous safety on one side and deep empathy and stewardship on the other. Okay, let's dive right into this. We've got a really clear roadmap for today, split into 4 sections. Section 1 covers the safety data sheet. Section 2 is all about managing chemicals and equipment. Section 3 shifts gears into the ethical care of organisms. And finally, Section 4 outlines safe disposal and release. Section 1, the safety data sheet. Okay, let's talk about safety data sheets, or what a lot of folks historically called the MSDS. These are mandatory 16-section technical documents. Now, a lot of people think these are only necessary for, highly reactive, dangerous acids or complex compounds. But here's the absolutely crucial detail. These are mandatory for every single chemical in your lab. Yes, that includes everyday common household products. If you bring dish soap, baking soda, or some vinegar into a lab environment for an experiment, you must have an SDS on file for it. There are literally 0 exceptions to this. Understanding how to properly read and navigate these sheets isn't just checking off bureaucratic paperwork. It is the fundamental blueprint for keeping your learning environment safe. So while you absolutely need to have the entire 16-section document available at all times, our sources highly emphasize 3 critical sections that you've just got to master. Imagine a spill happens right in the middle of a bustling lab session, or maybe a student accidentally gets something on their skin. You definitely don't have time to flip through 16 pages of dense text. Where do you look? Boom, Section 4, First Aid. You go directly there. What about when you're receiving a big order of supplies over the summer and need to know exactly where to put a brand new substance? That's Section 7, Storage. And when the lab is totally wrapped up and you've got waste on your hands, you flip to Section 13, Disposal. Memorize these specific section numbers because knowing exactly where to find this information in a pinch is what separates a chaotic, panicked response from a safe, completely professional one. Moving right along to Section 2, Managing Chemicals and Equipment. Getting your physical workspace organized properly isn't just about keeping things tidy. Proper organization is active disaster prevention. The sources are incredibly clear about the strict storage protocols that have to be followed to the letter. Let's look at 2 primary rules here. First, you have to store acids and bases completely separately. You never ever put them on the same shelf or in the same cabinet where a simple leak could cause them to mix and violently react. Second, keep all your flammable chemicals secured in specialized cabinets that are literally designed for flammables. You're engineering the environment so that even if a container fails, you've already prevented a catastrophic chain reaction. Let's move to and see how this builds into your daily routine. Because it's not just about the chemicals, right? It's about the equipment holding those chemicals. You need a strict mental checklist before any lab begins. Step 1, check all your glassware. You're looking for hidden hazards like tiny hairline cracks that could just shatter under heat. And hey, while we're on the topic of glassware, always make sure you're modeling accuracy by reading the meniscus of a liquid right at eye level. Step 2, check your electrical equipment. Ensure all those cords are properly grounded before anyone plugs anything in. And remember to model proper transport for heavier equipment too. For example, explicitly demonstrate the 2-handed carry method for microscopes, one hand firmly gripping the arm and the other supporting the base. Doing these physical checks guarantees the environment is actually safe and ready for learning. All right, transitioning now to Section 3. Ethical care of organisms. Ethical stewardship. This is the exact terminology used in the source text, and I really want to anchor us in this phrase for a moment. When you bring living things into a classroom, you are no longer just a manager of inanimate materials. You become an ethical steward. You're making both a philosophical and a deeply practical commitment to respect and protect the biological entities you're utilizing for education. Now, as an ethical steward, you are absolutely obligated to perform a continuous basic needs maintenance check. We're talking air, water, food, space, and shelter. Let's say you bring a native Texas pill bug into the classroom for an observation lab. You can't just toss it in a plastic cup and leave it on the counter over the weekend. You have to ask, does its habitat have proper ventilation so it gets enough air? Is the soil moisture correct so it has access to water? Does the enclosure actually provide adequate hiding spaces, like under a piece of bark, to prevent stress and offer genuine shelter? Providing these 5 basic needs isn't just a nice thing to do, it is your primary ethical obligation. Now, what's really interesting about this slide is how it bridges the gap between student safety and animal welfare. By actively modeling the gentle, ethical handling of that living pill bug we just talked about, you're actually accomplishing 3 massive things at once. You prevent lab contamination, you prevent potential injury to the student, and crucially, you prevent the mistreatment of the organism itself. Whether the specimen is living or preserved, handling it with care and respect is an absolutely vital lesson in scientific empathy. And guess what? Your students are going to absorb that lesson just by watching you. This brings us to a much broader educational standard, officially known as Competencies 003C. The daily classroom handling rules we've been discussing, they don't exist in a vacuum. They are deeply, deeply connected to the overarching goal of science education, teaching students how to actually apply scientific principles to analyze risks and ethical standards. When you demonstrate exactly how to care for a classroom organism, you are effectively teaching your students how to evaluate complex biological and environmental interactions out in the real world. You are directly modeling responsible decision-making.
And finally, Section 4, Safe Disposal and Release.
So, what happens when the lab is over? The experiment is totally done, the data is collected, and the bell is just about to ring. Honestly, this is often the single most vulnerable moment in any classroom, mostly because everyone is rushing to clean up and get to their next class. But listen, the end-of-life cycle for your chemicals and your organisms requires just as much rigorous, focused attention as the initial setup. So the crucial point is right here. These are your final, totally non-negotiable end-of-lab rules. First, let's look at the chemical rule. You must never pour chemicals down standard sink drains unless you are explicitly authorized to do so by Section 13 of your SDS. Just assuming a clear liquid is basically water and safe to dump is exactly how plumbing gets destroyed and local groundwater gets contaminated. Then, you've got the organism rule. No non-native organisms should ever, under any circumstances, be released into the local wild. Think about it in both scenarios. Your job is protecting the outside world from the contents of your lab. You are preventing chemical pollution on one hand and preventing massive ecological disruption from invasive species on the other. To put a finer point on that organism rule, if you absolutely cannot release them into the local wild, what in the world do you do with them? Well, the sources are incredibly clear on the approved pathways here. Non-native organisms must either be returned directly to the biological suppliers you originally ordered them from, or they must be safely maintained in your classroom for the entirety of their natural lifespan. And if you keep them, you're constantly ensuring that basic needs checklist is met every single day. There is absolutely no middle ground here. All right, we have covered a lot of ground today. We've talked about the critical everyday necessity of the SDS, the rigid protocols for storing equipment and chemicals, the profound ethical requirements of organism care, and those absolute, non-negotiable rules for disposal. It is a massive, massive responsibility to balance managing inanimate hazards while being a living steward. So I want to leave you with this thought to evaluate your own workspace. When the bell rings, will your daily lab practices hold up as the ultimate model of both rigorous safety and ethical stewardship? Thank you so much for watching this explainer, and keep learning.